All right, let's learn about atoms. So, essential questions for today's lesson is what is the basic structure of atoms? How is an atom's mass calculated? Which subatomic particles are electrically charged? Where are the three main subatomic particles located? And how do protons determine an atom's identity? All right, so first of all, what is an atom? It's really basic. It's the basic building block of ordinary matter. So if you want to think of all the matter in the world like a Lego set, an atom would be one individual Lego block. And we can have them by themselves, we can put them in different combinations to make new things, or we can just have like one atom, alone. The basic unit of a chemical element, so for example, gold, oxygen, mercury, iron, potassium, there's a whole list of elements, and we'll talk about the table that those are on in a couple of weeks. It consists of three basic parts: protons, neutrons, and electrons. And these three things are all called subatomic particles. So subatomic, so sub means like below. So it is smaller than an atom. So it is subatomic. It's a part of an atom particle. Subatomic particles. Protons, neutrons, electrons, all three. So the structure of an atom, it consists of a nucleus in the center. So the nucleus is here in the very middle. I think you guys learned about cells last year, maybe. So it's very similar to the nucleus of a cell. It's in the center. It's kind of like the main part. So the nucleus is in the center, and that's where the protons and neutrons live. So if you look here, the nucleus is just protons and neutrons. The electron cloud surrounds the nucleus and contains your electrons. And so these rings are referred to as orbitals or shells. I usually say shells. So it's like the nucleus is the small little center part, and then you have these shells around it that are just the electrons. The protons and neutrons are like fairly big as far as like an atom is concerned. The electrons are very, very, very small. Very small. So the two main parts of the atom are the nucleus in the middle and the orbitals or shells that surrounds it. That's this line here. So protons. Protons are positively charged subatomic particles. So the way I remembered this when I was in school, if you think about pros and cons. So if we have something and we say the pros of, school getting out earlier are these good things. The cons of it are these bad things. If you think of pro as being a good thing or positive, protons are positively charged subatomic particles, and they are located inside the nucleus. So they are included in the atom's mass. So we'll talk about the mass in a minute, but just make sure that you know that the protons count when we talk about the mass. So one proton equals one atomic mass unit, so AMU. That's just the unit we use when we talk about atomic mass because it is so small. You cannot measure atomic mass in kilograms or grams because it is so, so, so tiny. So we had to come up with a new unit to cover that. So atomic mass unit. One proton, one atomic mass unit. It's the same thing. So the atomic number of an atom is the number of protons. So as you go through the periodic table in a couple of weeks, we will talk about the atomic number. So like the atomic number of hydrogen is 1 because it has 1 proton. The atomic number of oxygen is 8 because it has 8 protons. And so just by looking at that table, that's something you can tell really easily is that how many protons are in each atom or each element is the number of protons in that element. And so it determines the element's identity. So we know what the element is based on how many protons it has. So 6 protons is carbon. We just know that that's just how it is. Okay. So what does the number of protons tell us about an element? It tells us it's part of its mass, but it also tells us its identity. So which element it is depends on how many protons it has. So protons basically give the element like its name. All right, let's see what's next. Neutrons. So neutrons have no electrical charge. They are neutral. So they have 0 charge. They are not positive or negative. Again, I remember it because neutrons are neutral. They have no charge. They are located inside the nucleus, so they like to hang out with the protons. And they are also included in the atom's mass. So one neutron is the same size as a proton, and so it equals 1 atomic mass unit. So the number of neutrons may not always match the number of protons. So just because carbon has 6 protons in the nucleus does not always mean it has 6 neutrons in the nucleus. Sometimes it's got some different things going on, and we'll talk about that later. But the neutrons and protons don't always have to match. That's why the identity is based on the protons, because the protons will always be the same. Neutrons, not always. So which of these apply to neutrons? So they make up part of the atom's mass. Yes. So when you add the protons and the neutrons together, that's how you get the mass of the atom. They're inside the nucleus. Yes. They have a negative electrical charge. We know that's not true because here it says they have no electrical charge. So neutrons are not charged at all, and they are measured in AMU. Yes. So they are in the mass, they're in the nucleus, they are measured in AMU, but they are not negatively electrically charged. They have no charge whatsoever. They're just kind of there. All right, electrons are the weird ones. So they are negatively charged subatomic particles. So because they are electrons, they have an electric charge. It just happens to be negative. They are located outside of the nucleus. So your protons and neutrons are in the middle, and your electrons are going all over. They're swirling around outside the nucleus. They do not contribute to the atom's mass. Electrons are so teeny tiny that they do not have enough mass to matter. Okay, so if you see here, 1 electron equals 1/2000th of 1 atomic mass unit versus our neutrons and protons, which are 1. So these are, you could fit 2,000 electrons and have the same mass as 1 proton. So these are teeny, teeny, teeny tiny. And so they're so small they don't really add to the mass, so we don't worry about them when we calculate the mass of the atom. In a neutral atom, the number of electrons is the same as the number of protons. So just like in math or when we figured net force, if the atom is neutral overall, then the negatives of the electrons equal out the positives of the protons, and they cancel each other out. So we will always have the same number of protons as protons as electrons, as long as the atom is neutral. And most of the time, for our purposes, they will be neutral. All right, so electrons exist outside the nucleus and do not contribute to the atomic mass. An electron has a negative electrical charge. Okay, so again, in a neutral atom, the electrons and protons are equal in number, so they cancel the charges out. Positive and negative, just like math. All right, so think about it. Scientists have used different models to represent atoms throughout the years. Each model changes slightly to represent some new understanding or information about atoms. So using your knowledge of atoms, what could you use at home to model an atom? More than one atom, right? So what could you use at home to kind of show the structure of how an atom is laid out? So you have protons and neutrons in the middle, and you have electrons swirling around outside the middle. Think about that. So here's the periodic table. Let me move myself out of the way. All right, so this table shows all the different atoms there are on Earth that we know of. They are always, not always, but they're kind of at times discovering or creating new ones. That's a whole other story. So this is the table of all the different atoms there are on Earth. It is called the periodic table of elements. There's one outside my classroom. I know you've seen it every day. So remember, an atom is the basic unit of a chemical element. And we will talk about elements and the periodic table later. For future reference, you do not have to memorize this thing. Okay? If you do, that's great. It is not at all required. Okay? So if you know, like I don't even have it memorized. I know like a lot of the basics of it. As long as you know how to use it, that's all we care about. Okay? If you want to memorize it for fun, hey, it's your life. Do what you want. Okay, so this is the table, has all the elements on Earth. As far as we know, these are all the elements in the universe. Okay, so from what we can tell on different planets and in different galaxies, the elements seem to be steady from place to place. So this is it, as far as we know. Okay, so atoms. What can we tell about this atom from its periodic table cell? So I'm sure you guys have seen all those boxes on the periodic table. They have a letter, they have numbers, they have names. What does this stuff mean? And again, we will go over the periodic table in depth in a week or two. So what can we tell about this atom or element from its periodic table cell? So we can tell the element's name. So it always has the name here. So this element is named nitrogen. It's a gas. It's the most common gas in the atmosphere. You breathe it in constantly every day. The element's chemical symbol. So the chemical symbol for nitrogen is just a capital N. And again, we will talk more about chemical symbols and what they mean and their differences next topic. The number of protons, which is also referred to as the atomic number. So the atomic number is this number up here in the corner. So the atomic number of nitrogen is 7. So that means in the nucleus of a nitrogen atom, there are 7 protons. Okay, that does not necessarily mean there are 7 neutrons, but there could be. The atomic mass number, which is the protons plus the neutrons, equals the mass number. So we have our mass number here of 14. So here we have 7 protons, giving us our atomic mass. And then we do happen to have 7 neutrons. So total, 7 plus 7, our atomic mass of this element is 14. Then how can we determine the number of neutrons in this element? So we would take our atomic mass, subtract the number of our what do you call that? The atom's name, the atomic number. So you take the mass minus the atomic number, and that gives you your neutrons. So it gives 14 mass total, gives 7 protons. That means 7 of those must be neutrons. So mass number minus atomic number equals neutrons. I could have just read it there and not had to think about it. That's okay. Okay, so let's talk about some of these. So each of these atomic models represents an element. Use the information on the periodic table squares provided to identify each element. Okay, so this one here, it has 1 proton and no neutrons. And it has 1 electron out here in this shell. So if it has 1 proton and 0 neutrons, we know its mass must be 1. So this one must be hydrogen. So this one has an atomic mass of 1. So that means it has 1 proton. Its atomic number is 1. Its atomic mass is also 1, which means that it's 1 proton. There are no neutrons because there's only, the mass is 1. So if you subtract the mass from the proton, there's 0. Anyway, so this one here is hydrogen. This one here, we have 7 protons and 7 neutrons. So if we have 7 protons, we're looking for the atomic number of 7, which is here, nitrogen. And since we have 7 protons, 7 neutrons, added those together, we have an atomic mass of 14. So our second one is nitrogen. Our third one, what does that say? We have 8 protons and 8 neutrons. So if we have 8 protons, then our atomic number has to be 8, which is oxygen. When we talk about bonding chemically, you're going to talk about oxygen a lot. So you're going to know oxygen is number 8 pretty early. So we have an atomic number of 8. We have an atomic mass of 16. This is those 8 protons plus those 8 neutrons equals 16 for oxygen. And then lastly, we have, 5 protons. And see, this one's weird. It has 6 neutrons. Sometimes it has more, sometimes it has less. So this one has 5 protons. So it must have an atomic number of 5. So that's boron. You don't really hear much about boron usually. So that's an atomic number of 5. But because it has 6 neutrons, we add the 5 plus the 6, we get 11 as our atomic mass. All right, so what is element number 1? It's here, hydrogen. And it is number 1. It is the most common element in the universe. So there's a lot, and it's number 1 for a reason. What is element number 2? Oh, this is these. That's what we did already. For the record, element number 2 on the periodic table is helium. Element number 3 on the periodic table is lithium. And number 4, I never can remember. Somebody tell me what element number 4 is. That one I don't know. All right, so describe the structure of an atom, including the masses, electrical charges, and location of protons, neutrons, and electrons. So I'll let you go ahead and think about that. And then how could you identify an element by its number of protons? Can you do that? If I tell you this element has 6 protons in its nucleus, could you tell me what atom or element that is? If I tell you this element has 26 protons in its nucleus, could you use the table to figure out what element that is? I think you could. All right, what questions do you still have that you need help on?